Hello, I'm Hannah Mutron, a library specialist at the University of Texas at Austin Libraries, where I focus on emerging technologies, particularly AI. The project I'm about to demo grew out of an interview I conducted with Corey Halachik, head of content management, all the way back in June of 2024. The initial idea was simply to see if AI had the potential to make a dent in our unprocessed music collections. At UT, we have a large backlog of audio materials that haven't been cataloged, and that makes them effectively invisible. Some are unique or near unique, some are important to local history. Until the collection is processed, they simply cannot be found. That's the problem that this project is trying to solve. Starting with copy cataloging, which is time intensive, but a good candidate for AI assistance because it involves the kinds of tasks that LLMs are well suited for, such as analyzing visual information, extracting information, and comparing records at scale. This project grew into a prototype over the last couple of years. I designed and developed the core pipeline, including image processing, metadata extraction, OCLC matching, and Alma integration with input and feedback from Corey Halachik, Whit Williams, Ben Chang, Aaron Choate, and Kayode Shola. Now it's being taken to production by Kay, who is in the process of adapting and refining the pipeline for use within specific workflows and content management. And so I thought it was a good time to demo the way that the pipeline works. The workflow is structured as a multi-step pipeline combining LLM metadata extraction and analysis with rules-based processing and external data sources. Here you can see our README, which contains more information. And now we're on to the config script. In here, you can set the models used, the max token counts, file paths, batch processing threshold, etc., all the parameters for the pipeline. And I'm going to show you now the run script. Once configured, the run script runs through a single script which executes each processing step in sequence. So it's going to start with file validation, making sure that the images are named correctly so they can be reliably grouped at the item level. And then in step one, the script is going to work through one item at a time. For each item, it sends a single message to, in this case, GPT 4.1 Mini, containing that item's images and a structured prompt, which is here. The model extracts metadata from the images directly, including, as you can see, title, artist, publisher, date, track listings. Once it finishes one item, it moves on directly to the next. After extraction in step 1.5, the metadata is normalized to ensure that we have valid pub numbers and dates that we can use for search in the next step. Using the metadata extracted by the LLM in step 1, in step 2, the system constructs a prioritized set of queries for the WorldCat search API. The queries are built from fields including the title, subtitle, primary contributor, publisher name, pub year, track listings, and product codes. There is a priority order. The product codes go first, as they're the most precise identifiers, and then we move on to kind of increasingly broad combinations as the queries are sent. The query combinations are run until 10 unique CD format records have been returned, and then the results are enriched with holdings data. In step 3, we're using another language model, this time GPT 4.1, to evaluate candidate records. It compares the extracted metadata from step 1 to the OCLC results from step 2, up to 10 of them. It chooses the best match, assigns a confidence score, and provides a brief explanation of its reasoning. The prompting is really important here. We've given specific instructions on what elements to prioritize and how to handle special cases, like non-Latin scripts and transliterated titles. We also give guidance on the confidence scoring so that it will be consistent. Step 4 is a quality control step. It compares track listings and publication dates from the extracted metadata to the same fields in the chosen OCLC record and downgrades results that don't match. In step 5, all records are classified into sort groups and the final output files are generated. Each record is assigned to one of 4 groups: held by UT Libraries, Alma batch upload, cataloger review, or duplicate based on the confidence score. A couple of the outputs that are most useful. Here we have a sorting spreadsheet to help in the initial sorting of physical items based on that group assignment. And then here we have a batch upload text file. It is pipe delimited with just the OCLC number, the barcode on the item, which is a unique identifier in our workflow, and the title. Step 6 generates a purpose-built HTML review interface combining the item images, the LLM extracted metadata, and the chosen OCLC record, presented together for efficient review and decision making. I'll show you what that looks like in a minute, but first I want to take a moment to show you some of the logs that we're creating. Here we have an OCLC search log with each of our queries and the responses that we've gotten back. Here is the full LLM response log from step 1 and the token usage log and the LLM response log from step 3. Here is the HTML review interface. It can be sorted by confidence or by barcode number. The confidence is in red here, green if it's high confidence. On the left, we see the item images. On the right, the nicely formatted chosen record from OCLC. This one is marked as low confidence, but it is correct. I believe it was downgraded because of some differences in song titles. Sometimes that does happen, and there is a balance between being too strict and not strict enough with these automated checks. So now catalogers can scroll through and confirm or reject matches. A few more examples. This is much more enjoyable than checking these results without an interface. And now we will export our decisions as a CSV, put them into the output folder. And over here in the cataloger decisions CSV, you can see that Foggy Mountain Gospel is there. We're going to check in our Alma instance. This is the sandbox, and it is not there. So that's the OCLC number that we found for Foggy Mountain Gospel, which was a low confidence record, but we approved it. Foggy Mountain Gospel is not yet in our batch upload file because it was low confidence, but we are going to run our step 7 integration script and check again afterwards. Step 7 creates this original outputs folder, and the original batch upload file will be there. And in our new batch upload file, we can see that Foggy Mountain Gospel is there. Now that we have checked our results, we will need to batch upload to Alma. For each line in our batch upload file, the script checks again that the OCLC number doesn't already exist in our Alma instance. If it's not there, it's going to fetch the full WorldCat record via the Discovery v2 endpoint, or fall back to a brief record and build mark XML from it. It imports this mark XML to Alma as a new bib record and gets back an MMS ID. It then unsuppresses the bib so it's immediately visible, creates a holding, and creates an item. So now we're going to look at Alma Sandbox again, now that we have our records. And you can see Foggy Mountain Gospel is there now. Here we can see the bibliographic record, the holding, the item, the pre-configured location is there, and there is an item with the barcode, the material type, the receiving date, and you can see here we also have an internal note to record the provenance of the record itself. Throughout this process, we've been generating a CSV with the MMS ID, holding ID, etc. for every record that we've successfully imported. And that is the full process. This project was designed to explore how large language models can be used within a structured system, one that takes advantage of their strengths while accounting for their limitations. They are very powerful for tasks like metadata extraction and comparison, but they're not inherently reliable, which is why in this workflow we have combined them with validation steps, external data sources, and clearly defined points where human review can be implemented. The goal is not full automation, but a system that expands what we can do in cataloging while still allowing for and even encouraging some control over quality and decision making. I designed and built this pipeline as a prototype, and I am very happy to report that it is now being adapted for production use within content management by Kayode Ishola. We have a GitHub repository with the code for this core pipeline. It is fully open source, and we hope that other institutions will adapt it for their own music collections. If you have questions or comments, please get in touch. Thank you so much for your time and attention.